Hello friends, welcome to Anuniverse Double 2. In this video, we will try to solve the numerical that is based on inclined plane surface submerged in liquid. So firstly, I read the statement of the numerical. A trapezoidal plate measuring 1 meter at the top edge and 1.5 meter at the bottom edge is immersed or submerged in water with the plane making an angle of 30 degree to the free surface of water. The top and bottom edges lie at 0.5 meter and 1 meter respectively from the surface. Determine the hydrostatic force on the plate. So firstly, we try to draw the diagram on the basis of the given statement. So I try. This is free surface of water and this is the liquid. In which trapezoidal plate that is submerged. So here two conditions are given and basically I want to draw the trapezoidal that is like that. This is the top edge that is A, this is the bottom edge that is B, and this H that is the depth, and this is the center of gravity. So according to this is the shape of the trapezoidal, and in the statement this is the top edge, the trapezoidal plate measuring 1 meter at the top edge. So this distance is given, that is 1 meter, and 1.5 meter at the bottom edge, this is 1.5 meter. We can say A equal to 1 meter, B equal to 1.5 meter, and this H is not given. We need to calculate this value, and the plane making an angle of 30 degree to the free surface of water. But next, the top and bottom edges, this edge and this edge, this is the top edge, this is bottom edge, these are lie at a distance of 0.5 meter and 1 meter respectively from the free surface. So on the basis of the given statement, if we plot this diagram, so the distance of this edge, this is the top edge, that is at a distance of 0.5 meter. So if I plot this point, firstly I plot the plane of this, the top view, this is the plane of this trapezoidal. It makes angle of 30 degree. Suppose it is at a distance of 0.5 meter. So from here I can plot, this is the top edge, this is A, that is equal to 1 meter of the trapezoidal, and second part that is at a distance of 1.5 meter. Suppose it is 1 meter. So from this line, this is the bottom edge. So this is the B, that is equal to 1.5 meter, that is given, and this is the trapezoidal plate that is immersed in liquid, and this is H we need to calculate, and this is the center of gravity, and this is the distance that is Hg. So we need to find out the hydrostatic force. So firstly I write down the hydrostatic force. On the trapezoidal plate. So that is, we need to find out the F, that is rho g A h bar. And as we know, this rho, that is 1000 kg per meter cube, g, that is 9.81 meter per second square, and next parameter we need, that is a, this is area, and area of this trapezoidal, that is equal to a plus b by 2 into h. So the value of a, that is given 1 meter, value of b, that is given 1.5 meter, but the value of h, that is not given. So we need to calculate this value for getting the area of the trapezoidal section. So for getting this value, and as we know, this is the G point that lies at a distance of h bar from the free surface of liquid. So here, if write the naming here, this is A, this is B, this is C. So A to C, this is also equal to H. If we find the value of AC, we can easily find out the value of H. So if I plot a suppose I plot a rectangle, this is a rectangle ACD, and it makes also angle of 30 degree, this is 90 degree. So this is 0.5 meter, this is also 0.5 meter, and the distance AD, this is equal to 1 minus 0.5. This distance, that is 1 minus 0.5. So this is a right angle triangle. So I can write here, from triangle ADC, that AD upon AC, this is equal to sine theta, and here AC, that is equal to AD upon sine theta, and AD, that is equal to 1 minus 0.5 upon sine theta is 30 degree, and this is equal to 1 meter, and this AC, that is equal to H. So from here, that is H equal to 1 meter. So from here we can find out the value of area, that is A, this is 1 meter, B, that is 1.5 divided by 2 into 1. So that is equal to 1.25 meter square. This is the area. Next we need to find out the value of h bar. So this is the h bar, and as we know, this is h bar, and for getting this value we need to calculate the value of this distance. If I got this distance, this is the AB. If I plot another triangle, ABE, this is the another triangle ABE. So from this triangle, if I have this distance, I can easily find out the distance, that is h bar, because this h bar, that is equal to 1 meter minus AE. If I write here h bar, that is equal to 1 meter minus AE, because this total distance is 1 meter, and from this point to this point, at this point to this point, both are equal. If I subtract AE from 1 meter, I can easily find out the value of h bar. So from triangle ABE, so for this I need to get the value of HG, and in trapezoidal section, the HG, that is equal to h by 3, that is 2a plus b upon a plus b. So A is 1 meter, 1 by 3, that is 2 into 1, that is given B, that is 1.5 divided by 1 plus 1.5, and finally HG, that is 0.467 meter. So I take the triangle AEB. Now from triangle AEB, from this triangle AE upon AB, this is equal to sine theta, and AE, this is equal to, that is AB sine theta, and from here H bar, that is equal to 1 meter minus AE, and that is 1 minus AB sine theta, that is 1 minus AB, that is equal to this distance. So that is 0.467 sine 30, and this is equal to 0.7665 meter. So this is the value of H bar. So now I substitute all these values in this equation, then I can easily find out the value of hydrostatic force. So F is equal to rho G AH bar, rho that is 1000, G that is 9.81, A 1.25, H bar that is 0.7665. So finally I got F equal to 9.399 kilonewton. So this is the hydrostatic force on the trapezoidal plate. So friends, in this video we have learned how to solve the numerical that from inclined plane surface submerged in liquid. If you like this video, please share with your friends and students. Don't forget to subscribe Anuniverse 22 for getting the notification of video on various topic of mechanical engineering. Thanks for watching. Have a nice day.